Unit 1, Lesson 2, Part 2. Okay, so let's just review D through H here. If you already have it written down, you can just chill and ask a question if you like. But the functions f and g on the previous page were 2x plus 1 and x minus 3. Write the expressions for the functions f plus g of x and f minus g of x. So if we just do like we just did, we're adding f and g. 2x plus x is 3x. So we got... All right, so we got f plus g of x is 3x and then negative 2. Okay, remember when we did those graphs, the f plus gx was up 3 over 1. So you kind of recognize those slopes, okay? So you're seeing that it's all coming together. F minus g, order doesn't matter here, so it's 2 minus 1. That's 1. 1 minus a negative 3, so it's plus 4, minus and minus. Okay, that's just simply just adding and subtracting the two functions to create a new function of their relationship. Okay, that's all we're doing. Okay. Okay, when you do this, they're going to be the same. You can just write same if you want. That's just putting your graphing calculator. Okay. The domain and range for these is very simple. The domain is all reals, so you can do the XER, or you can do infinity to infinity. And the range is the same thing because why? What type of functions are these? What is f plus g and f minus g as functions? You guys should be able to say this right away. Linear. They're linear functions. There's no restrictions on what x can be, and they continuously go up and down. So the range and the x is unlimited. Okay. Now, determine the values. So we're going to sub 10 in. So if I sub 10 in, we just got to put that in right here. So take 10, I put that right there. 3 times 10 is 30, minus 2. Is 28. That's it. Just evaluate and just plug that into the work you already did. F minus g, put a negative 10 in. So we'll put this negative 10 right there. What's negative 10 plus 4? Negative 10 plus 4. Come on, let me make you guys say something. Negative 6. So man, his thoughts up here. Okay, negative 6. All right, we're waking up. That's fine. Okay. In this example, the sum and the difference of two functions of degree 1 are also functions of degree 1. Can you find two functions of degree 1 whose sum or difference is not of degree 1? And this is what we talked about a little bit yesterday really quickly. Essentially what would happen is your x's would cancel. Okay, so if you're adding 2 of degree 1, maybe you have a 4x and a negative 4x. If you did that, they'd cancel. You no longer have a degree of 1, right? Because you just have a constant. So this is what they're saying. So here's an example. If I did f of x equals, let's just say f of x is 3x minus 9. And then I say my g of x is negative 3x plus 2. If I add those functions, you see the x's cancel. So it no longer has a degree of 1. That's what it's asking for an example of. Okay, you can think of your own if you'd like. All right, so that was the finish of the linear. Now we get to the part where you guys were really looking frustrated yesterday. At the end, you're also wore out. And we're going to the quadratic part. Okay, so we're going to the parabolas. Okay. All right. So the graphs of two quadratic functions to the right is f of x and g of x. They don't tell you the functions, but they just say use the graphs to sketch the graph of f plus g of x and f minus g of x. Okay, so essentially, this is what I was trying to explain yesterday, is that they're just kind of using like a mini table here. And so they say, we'll use these x values. And then here is your f plus g of x. And here's your f minus g of x. And they just kind of came down like this. To get some points. We're just getting some points to graph it. Because we don't know what the functions are. So we can't just say, oh, it's this. They're wanting to get some points, just go ahead and give kind of a general sketch. So the values they pick for x, and usually they just pick a wide range. So these aren't, you could pick different values and still get a sketch, okay? They started at -3, and they went all the way to +7. See if I have enough here. Close. Okay. So those are the x values they're using. Now again, the x values are inputs, guys. So like we plug in that input to all the functions, to f of x, to g of x, to f plus g of x, to f minus g of x. That input is just a value we plug in. The output's what changes, right? Functions give you different outputs based on if they've changed. You know, you have different lines, you put in an x, you get different numbers if it's a different line, right? So that's the idea. So what they want you to do visually is see, go to -3. Here's -3. Okay, remember we talked about this yesterday. These go by 2, so be careful. This is at 1. It tells me that in the beginning. It says that these are all marked with integer coordinates, so there's no decimals. That's kind of your giveaway. So this right here, this function is the g of x, right? So g of x, okay, yeah. So g of x at 3, -3, is 1. You just write this on the side just for your own. Okay? What is f of x at -3? (24). So then what do you think we do with those two values? We're doing this row. Just add them. F plus g, right? 25. This is the point. -3, 25 is the point of f plus g. Okay? So let's look at this here. Let's go ahead and do it in blue, okay? If I can get it clicked there. So we're going to do this one in blue so you can see a little bit of difference. So -3, 25 is where I want to be. 24, I want to be right there, just a little bit above. Oh. See that? Okay. I'm going to do 2 more for the f plus g, and then I want you to finish it. Okay, I'll walk around and help you. So let's do -2 and -1 together. So if I go to -2 on the graph, remember, we're looking at the graph. I'm not plugging anything in. We don't know what these functions are. It didn't tell us. Okay, so if I go look at -2, here's -2. Okay, g of x is 4, 2, 4. So if I go g of -2, I get 4. F of -2, I get 12. 10, 12. So right here, you would put a 12. Oh, yes, you do add them. Thank you. Forgot that main part there. Sorry. Oh, no. I do have the back button somewhere, but it's OK. All right. Sorry, guys. -2. All right. So what was this one? 25, right? And then, yeah, 12 and 4. Thanks, Ollie. So 16. So the point is -2, 16. That's what we're going to plot. -2, 16. Right there. OK, one more, and I'll pause it, let you do top row, and we'll start the second row together. G of -1, f of -1. You don't have to write those out if you don't want. It's just a little organizational tool. All right, so from at -1, g is at, or that's not g. G is up a little bit higher. See how g is just slightly above 1? So g is actually at 5. Do you guys see that? Okay. And then the f is below it barely, is at 4. 5 plus 4, 9. Okay. Just go ahead and get those. So -1, 9. That puts us right here. Okay. Go ahead and you finish those off. I'll pause the video. All right. So Denise already helped us with 0. She got 4. So 0, 4 is a point. So that's right here. Okay. Leah, do you have the 1?
Yeah, no, 1.
You got 1. That's good. So 1, 1. So that's kind of half. Or no, that's here and right there. Okay. Spicer, do you have 2? 2 is 0. That's correct. Good. Okay. 3. Dom, you got 3? A 1? Yep. So we're seeing the turn here. You guys see that? It's starting to turn. Okay, Andy, do you have 4? 4. Yep. Okay, good. 5. Let's see. So 5, I have 9, so we can get to 9. So let's see. What's that? Using this? Oh, I see what you're saying, because this is gone, huh? Gotcha. Yeah, so that is harder to see because of that. You're right. This one's not a good. So that's pretty much a stopping point of what we can see. Okay, you are correct. Good. The way you can tell, okay, is look at this. See this here? This is obviously a what? It's a pattern. It's a parabola, right? See how these are mirrored? So see that's at 9? I think that's how they did it. Okay, they just say, hey, that's at 9 as well. Okay, but you're right. We can't see, so you're correct. We can't see the subtractions. Okay, it's a good point. So, okay, so when it comes to that question, his point was the 5, you can't see what the graph is. This one, you can't really quite see it either. But we can start to see our shape start to like kind of settle in. So we have these 2 are mirrored, these 2 are mirrored, that looks like the vertex, those 2 are mirrored, 5 and 9. Okay, so then what about 6? What is 6 mirrored with? So 6 looks like it's going to be roughly here, which is 16. Okay, I think we have a good enough image to draw this now. So we can just draw this up. Draw this up. Okay, so that is the blue, F plus G. Okay, so now we can do F minus G, which is nice that we have these because we can just subtract them. So 24 minus 1, okay, 12 minus 4. So we have these kind of built. Okay, so 24 minus 1, we can try to switch it up here to green. So that's 23, 24 minus 1. 12 minus 4 for 8. 4 minus 5, we're into the negatives. Okay, and this one they stopped at 3, which let's see if we can get that. So 0 would be 4, nope, 0 minus 4, so it'd be negative 4. Okay, at 1, like 0 minus 1 for negative 1 again. So we see the bend here. Okay, and then it does actually mirror. It goes 8 and then 23. Okay. And so now we can graph this one. So negative 3, 23. Okay, and then we have negative 2, 8. 2, 4, 6, 8. We have negative 1, negative 1. And 0, negative 4. Okay, and then we're back to mirroring it. 1, negative 1. 2, 8. And 3, 23. And there's your other function. So you got green here, F minus G, blue, F plus G. So now what we're going to do is they tell us what the functions are, and now we're actually going to just combine like terms and see, oh, they do. They are parabolas. They are the ones we just drew. We obviously just did an investigation there, guys. You're not going to do that all the time. That was to make the connection between the points and how they are shared. Okay, so that was, the visual people, that's the visual way of kind of undoing this so that you can see what the parabolas are doing when you combine the functions. So let's just do f plus g here. Or let's just keep going here. We are, Cassie, could you just tell me what f plus g is here? Just do these right here. So the adding the functions.
Oh, there.
Yeah, nope, that's good. Yeah, they give us the functions now. So go ahead and just.
X squared
Good.
minus 4x.
F plus g of x, you said x squared minus 4x plus 4. Good. Okay, and then next one over, Bobber, do you want to try the f minus g? So just make sure you do the right order here. So go this minus this. Don't forget your negative, negative. Sure. Cole, you want to recover for her there? You lost? Oh, man, just going to sit there and take it or what? That's not how it works. We have these two functions. We're doing f minus g. This function, f, minus this function. So it's 2x squared minus a negative x squared. So that means plus. So it's going to be 3x squared. Okay? Negative 2x minus a negative 2x means plus, right? So they're gone. Yeah, they cancel. Good. Okay, and then we have a 0 constant minus 4, so it's a minus 4. So that's your f minus g function.
Wait, why a minus?
What's that?
Why is it a minus?
Because this one we're minusing, so it gets.
0 minus 4 is minus 4.
Yeah. You got it. Okay, now if you look at these, 3x squared minus 4, that's just a parabola stretched by 3, moved down 4. Look, we're right here. This one's just off a little bit, but it's right here. That's right where it should have went through, right there at 4. Okay? All right. Okay, anybody else want to admit that they're lost? Do we need to get not lost? Still lost? Okay. So we have to, all we're doing is we're just adding these with like terms, okay, and subtracting these. This part here, we can go over that later again if you'd like, in terms of matching the points. But this right here is kind of the, I'd say, the summary we have to all have down today. You have to be able to combine like terms for two functions. Okay? All right, so let's look at C. All right, so we're going to do, all right, so we're going to go ahead and, C is the same. The graphs that we drew, they're going to be the same that you'd see. How about the domains and the range, or the domains, just the domains for the two functions? Well, both those functions we created were both what? No. They're quadratics, right? They're parabolas. And so domains of parabolas are all pretty good, right? Because they just grow laterally forever. So these are both just going to be XER, okay? Because they're both quadratics. We have no issues with X. X is fine. Okay, E is the same thing they talked about last time. You just have to have the same x squareds. Okay, so if my f is 3x squared minus 2x plus 2, and my g of x is negative 3x squared plus 5x minus 8. If I added these, those would cancel. I'd no longer have a quadratic. That's what it's asking you. Yeah, it's just a really weird way of wording it. They're just pretty much saying, how would you no longer have a quadratic? Well, you have to have the same coefficient. That's what they want you to know. That's how you change. Okay. All right, last page here. These are more just straight examples. So if we were just being too big a scope for you, these are more directly applied. This is like the practice problems you're going to do. Okay? Got to hustle because I do want you guys to get on the whiteboards and get some stuff done together today. Okay? All right, so right here, f of x plus g of x. And what's that expression? Okay, I'll go and take care of these for you. So f of x, X cubed plus x cubed. 2x cubed. Negative 2x squared, there is no x squared, so it just stays. I'm going to go ahead and write, I like to write in order, so I'm just going to take this negative 2x as well and just write that, because there's no x here. And then we just add the constants. I'll stop there for a second. You can ask a question if you like. Okay, that's all. Okay. In part 2, when you minus, you have the same problem. So like nothing's going to happen with negative 2x squared. We are going to flip the sign on the 2x because we're minusing a negative. So that's the kind of stuff you got to be touchy about. Be careful. So x cubed minus x cubed, so we don't have any x cubes anymore. So there's x cubes gone. Negative 2x squared, there is no x squared, so that's my leading coefficient now. I just told you to watch for the minus and minus. No x minus a negative, so it's plus 2x. And then 6 minus 6 is 0. So we had a lot of things go away there. Let's go. Didn't really leave myself much room here. The 2x is there. Yeah, because there's no 2x here. We're minusing a negative, so we just put the yes. Okay, so to answer these questions, complete the following statements. F of x plus g of x is a blank of two functions f and g. And so what they're looking for is, like, what's the mathematical term of what we're doing? Sum, good. And then they want us to write the answer down there now. Okay, so that's how it can be rewritten. Okay, and then for part 2, not a little bit small space here, but difference is what they're looking for. Okay. And they do the notation here. That's an x there. All right. Like I said, that's a little more direct, right? Just straightforward. Questions on that? Okay, we're just kind of combining like terms, right? Okay, don't beat yourself up and make you feel like it's harder than it is. So with these same ones we just did, we're going to evaluate these numbers now. So the nice thing now is we can take this negative 2 and we can put it in for these x's. You put negative 2 to all three of those x's, right? And then we're going to get a value. Keyword evaluate. So we're going to go 2 times negative 2 cubed minus 2 times negative 2 squared. I'm just plugging in the negative 2. And then 2 times negative 2 plus 12. Yeah, so we're going to have a negative 8, so this is negative 16. That's a positive 4, but we're minusing 8 plus 4, because a negative times a negative, and plus 12. So yes, you can kind of see that there. 4 plus 12 is 16, and a negative 16, so those cancel. That's your answer, negative 8. That's all that's left. Okay. No, because negative squared is positive and it's already minus. So negative 2 squared is 4, and then times negative 2.
Okay, but on the other one, since it's
Yeah.
On the
On the
-2 times -2.
first one? Yeah. So this one, because it's a negative times a negative, this one, it's squaring it, making it positive, then times a negative. That's the difference. The square is taking care of it. Okay. Then they throw in a radical for you, so f minus g. So we take this radical, we put it in right here and right here. Okay, so we got negative 2 times root 6 squared. We like that because that cancels, right? Plus 2 times root 6. You can't do much of this. Okay. Does it want? It doesn't say it wants. Yeah, you don't write decimals. You're just going to pretty much do this right here. These cancel, right? Squaring a radical. And then what's 2 times 6? Yep, so this is negative 12 plus 2 root 6. That's the exact value answer. That's all you can do there. Okay. Okay, we are going to, we're going to stop here. We'll talk about the profit revenue as like the warm-up tomorrow. It's not bad, so we'll do that instead. But I do want you to get up on the board today. So